So the safety precaution is as follows. The appropriate biosafety practice should be used when handling the specimen and the reagent. So you should apply the biosafety practice when you handle the specimen and the reagent. For example, Drapkin solution and those control, and also in the specimen when you handle the blood samples of the patient or of the people. So now let's move on procedure now, but actually I will not going to explain about procedure because that is the part of practical, so I'm just skip the part of procedure. And now let's move on in limitation. So now we have limitation now. So we just know the limitation that is obtained or that is found in this method of cyanide method or hemoglobin cyanide method. So the first limitation is say that potassium cyanide is very poisonous and must be kept locked at all times. So potassium cyanide is very poisonous. When I say poisonous, I think guys, you know, poison. Potassium cyanide, it is a poison. So you have to keep it locked at all times. So if you are ready and you are ready to use that potassium solution or Drapkin solution, you have to lock it by using its cap at all time in order to ensure that you provide safety there. Also store Drapkin solution in the brown reagent bottle because it decomposes on exposure to light. So you have to store your Drapkin solution, a solution which contains potassium cyanide, potassium ferricyanide, and other chemicals. So you have to store it in a brown reagent bottle because you know that reagent is more sensitive with a sunlight, so it can decompose by using sunlight, or when you expose it to the light or to the sunlight, it will going to decompose. So that is the limitation. So actually now you know that when you want to store the Drapkin solution, you have to store Drapkin solution in a brown reagent bottle because that bottle will protect the Drapkin solution from decomposition to the sunlight or to exposure to the sunlight. Also preferably use glass cuvette. When you are doing this method of hemoglobin cyanide method, actually as I told you, we just use an equipment known as calorimeter. So in the calorimeter there we have cuvette. The cuvette, this is the I can say the apparatus which is used to pour that fluid which you want to measure by measure the maybe optical density by using that calorimeter. So the cuvette, we just preferably to use the glass cuvette. So if plastic cuvette are used, make sure they are free from scratches. So the side of cuvette with the arrow mark must face the light pathway. So you are supposed to see the side of the cuvette which is narrow, which is arrow.